For question 8, I want to actually check whether the students understand that a displacement time graph basically is a snapshot of how where each particle is from the undisturbed position, and it is like a photograph, right? And I want to see whether they understand what speed of wave is. So I designed this question. So anyway, if you look at this question, you have a displacement distance graph that overlap on one another. And the yellow waveform shows you how the wave looks like at time equals to 0. And then after that, I unfreeze the time. I freeze the time again at time equals to 0.15 milliseconds, right? Milliseconds, got prefix, millisecond. And I take another photo, then after that I overlap the photos together and you get this graph that you see in your question. First question is basically a giveaway. A wavelength is just from here, then it goes down, go up and end up here. So if you read carefully, you'll be able to get the wavelength as 1.6 millimeter, right? Part B is the one that I want to check whether you understand how the graph comes about and whether you can appreciate what the speed of wave is. So for those of you who got it wrong, let me give you an illustration, okay? So now I have a wave thing over here. Let me reset it such that it looks like the one on your graph. Give me a minute. Okay, so now this situation looks quite similar. Oh, cannot. Your one is time equals to 0 is the yellow, right? It goes down and then up. Okay, it goes down and then up. Yeah, miss it. Miss it. Okay, so this wave shape is the same as this. Goes down, then up, right? Okay. So now what happened is that the timer is at 0.00000 times like that, right? The crest is over here. If you read, it's about 3.1 cm. So now I play it. And at 0.24 seconds, the crest has now moved to 4.7. So how much has the wave moved? We look at the crest, right? Just now it was at 3.2, now moved to 4.7. So what's the distance moved by the crest? 4.7 minus 3.2, right? And what is the time taken for this to happen? 0.24 seconds if you look at the timer at the bottom right hand corner. So what's the speed of wave? Isn't the speed of wave the distance traveled by the crest, that one crest, over the time taken for this travel to happen? So actually the speed of wave is not always v equals to f lambda, but it can also be expressed as the distance traveled by one crest over the time taken for that to happen. Do we have this information from the prelim question? Yes, you can see initially at time equals to 0, the crest is here. And after t equals to 0.15 milliseconds, the crest have moved a certain distance, which can be measured by the x-axis, which is here. So by doing so, we can actually find out the distance traveled is about 0.1, 0.2, 0.3. So it's about 0.3 millimeter. And the time taken is 0.15 millisecond. So with this, you will be able to appreciate that your speed is equals to 0.3 millimeter divided by the time, 0.15 millisecond, and you can see that the milli will cancel off each other. So after you do the math, you will be able to find that the speed is about 2000 speed is about 2 meter per second, which is 2.0 meter per second. So this question is designed with the intention to see whether you are flexible enough that if you couldn't find the frequency, or whether you can switch your approach to find the speed of wave by looking at how much the crest has traveled, rather than to always substitute f and lambda, because in this question to find the f, it actually requires a greater effort. Yeah.